Microtunneling Works. The Japan Microtunneling Association. Overview of tunnel construction methods. Tunnels provide infrastructure that is essential to our lives, such as transportation, railways, roads, humanitarian, etc. Water resources, underground rivers, underground reservoirs, etc. Utility lifelines, water and sewage, electricity, communications, gas, utility tunnels, etc., which are installed in underground space. Tunnel construction methods include mountain tunnel construction, cut and cover tunnel construction, shield tunnel construction, and pipe jacking construction. Among these, the pipe jacking method is mainly used for social infrastructure pipelines, sewerage, water supply, electricity, communications, gas, etc., in urban areas. The pipe jacking method can be constructed with relatively little disruption to traffic. In residential areas, a soundproof enclosure can be around the shaft area. About the pipe jacking method. The pipe jacking method involves constructing a starting entrance and an arrival shaft as shown in the diagram, installing each piece of equipment, and constructing a pipeline by forcing the jacking pipe into the ground using the jacking force of a hydraulic jack. There are various types of pipe jacking construction methods, and the work varies depending on the nominal diameter, inner diameter of the jacking pipe, but a team of 4 to 8 people work on each at each station, inside the pipe, inside the shaft, above ground. Work practiced by technical intern trainees in Japan. 1. Preparation work. 2. Excavation work. 3. Equipment removal work. 1. Preparation work. 1. Installing crane equipment above the shafts. Assembly and disassembly work requires skilled training and special education qualifications for hoisting sling work. 2. Installing equipment inside the shaft. The thrust wall evenly transmits the reaction force of the main hydraulic jack to the ground behind it, supporting the jack. Construct by pouring concrete using formwork. The press boards disperse and transmit the reaction force of the jacking force back to the thrust wall. Press boards are installed in front of the thrust wall. The starting entrance prevents leakage of groundwater and lubricant. The water stop ring is welded to the retainer, and concrete is poured using formwork to construct the structure. The pipe jacking stage is installed firmly and stably, with the specified height, slope, and direction of excavation. It is assembled using steel H-sections and secured with bolts or welding. The main hydraulic jack uses hydraulic pressure to push the excavator and jacking pipe into the ground. The main hydraulic jack is secured firmly with bolts, etc., or installed on a frame. 2. Installing equipment, ground level. The injection equipment, for lubricant and backfill, is used to supply those materials necessary for pipe jacking. Lubricant is injected during excavation to reduce the frictional resistance between the jacking pipes and the soil. The lubricant made by the injection equipment is pumped into the tunnel pipe through piping, and then injected through the grout holes of the pipe. The injection materials are mixed in the injection equipment and then pumped through piping installed above ground, in shafts, and in pipes. Piping above ground and inside the shafts is installed during preparation work, but piping inside the pipes is replenished and laid for each jacking pipe unit. Backfill injection is performed after excavation is completed, to fill gaps between the jacking pipe and the ground and prevent the ground from loosening. The lubricant backfill made by the injection equipment is pumped into the tunnel pipe through piping, and then injected through the grout holes of the pipe. During injection, the injection pressure etc. is monitored. Equipment for removing generated soil will be installed when necessary, depending on the construction conditions. 3. Installing the excavator in the shaft. Hoisting an excavator requires a skill training course or special education qualification. When lowering the excavator, signals are used to communicate between the ground and the inside of the shaft to ensure safe work. Various types of excavators are used depending on the nominal diameter, inner diameter of the pipe, construction method, microtunneling target ground, etc. The excavator will undergo a trial run before it is launched. 4. Face cutting at the start. The retainer material, steel sheet piles, etc., inside the starting tunnel entrance is cut to match the outside diameter of the excavator, and is removed so that the excavator does not hit the retainer material. Gas welding qualifications are required for retainer cutting work. Work practiced by technical intern trainees in Japan. 2. Excavation work. 1. Lowering pipes, joining, and press fitting of jacking pipes. To lower the jacking pipes, use special hoisting hardware or wire rope. A qualification is required to operate the crane. Jacking pipes include reinforced concrete pipes and PVC pipes. Jacking pipe joining. Personnel placed at the bottom of the shaft will perform the following tasks. 1. Inspecting the water stop rubber ring. 2. Lowering pipes, jointly with people on ground level. 3. Applying bonding lubricant. 4. Connection and replacement of cables, excavator power supply, operation cable, tunnel light cables, etc., piping, lubricant material, ventilation, etc. 5. Adjusting the height and direction of pipes that connect to the pipe that has already been laid. 6. Joining pipes using a main hydraulic jack. The press ring is installed at the rear of the jacking pipe to evenly transmit the jacking force of the main hydraulic jack to the jacking pipe and protects its end face. The strut is installed between the press ring and the main hydraulic jack when the stroke of the main hydraulic jack is insufficient. Excavation work. Excavation work is carried out depending on the soil quality of the ground, while stabilizing and protecting the face, jacking pipe, reaction bearing, etc., with appropriate placement of the main hydraulic jack, jacking force, pressure of the main hydraulic jack, and excavation speed. Press fitting proceeds to exactly to the specified height, gradient, and horizontal direction. Initial excavation. In the early stages of excavation, the excavator is likely to drop or roll, so the excavation speed is reduced and the excavator is operated carefully. Depending on the construction conditions, the excavator and main hydraulic jack can be operated remotely. In addition, when operating the excavator from inside, do so while communicating with the operator of the main hydraulic jack. 2. Installing the intermediate jack. The intermediate jack on ground level. The operating status intermediate jack is monitored while it is in use. 3. Lubricant injection and pipe ventilation. Lubricant is injected around the pipe to reduce the frictional force of the soil. The injection fitting for lubricant injection must be installed in the appropriate position. 4. Excavated soil is carried outside the shaft and disposed of. 5. Pushing the excavator out. After the excavator reaches the arrival shaft, install the arrival exit and machine support stage in the arrival shaft, perform face cutting at the arrival shaft, and push out the excavator while communicating between the start and arrival shafts. 6. Removal and recovery of the excavator. Work practiced by technical intern trainees in Japan. 3. Equipment removal work. 1. Remove equipment from the shafts and above ground. The equipment will be used again, so handle it with care. 2. Injecting backfilling material through the injection hole of the jacking pipe. Backfill injection is performed promptly after excavation is completed. The injection fitting is connected to the appropriate location. During injection, monitor outflow from the joints and start and arrival shafts. 3. Filling joints with mortar. When filling with joint mortar, joint grooves are cleaned thoroughly. Joint mortar filling is carried out by a specialist company. Pipe jacking construction engineer examination. The Japan Microtunneling Association aims to improve the technique of the pipe jacking method and spread it correctly, and conducts the pipe jacking construction engineer examination, once a year, to examine and certify the technology and skills related to the pipe jacking method. Successful registrants are granted the qualification of pipe jacking construction engineer. To that end, the pipe jacking engineer qualification is a qualification that certifies the technical level of an engineer. Seminars. The Japan Microtunneling Association holds lectures and technical seminars on topics related to pipe jacking methods, such as technical information, safe construction, and design cost estimation. The Japan Microtunneling Association. Purpose: conduct research and investigation on pipe jacking methods and construction, and contribute to the promotion of social and public welfare. Membership. Regular members, 69. Special members, groups, 43. Supporting members, 55. Business. Research on investigation on the pipe jacking method and construction technology. Research and investigation on demand trends for materials and equipment used in pipe jacking construction, and construction cost estimation. Research and investigation on ensuring safety during pipe jacking construction works. Publishing and promotion of technical books related to pipe jacking methods and construction. Implementation of training sessions and seminars on pipe jacking methods and construction techniques. Certification of qualifications to improve pipe jacking construction technology. Awards and grants to those who have contributed to the development and dissemination of microtunneling technology. International exchange regarding pipe jacking methods and construction techniques. Cooperation, requests, and opinions regarding the measures of policies of public agencies, etc. We're looking forward to the day when we can work with you all in Japan.